In this problem, I'm going to start the solution simply by drawing a little sketch of what I see in my mind. And that would be a cliff with some diver starting from rest, and then free falling, greater distances, equal intervals of time. And then I'm going to make a little list of initial conditions, like, I'll say the initial height, 125 meters, the final height, ground level, 0 meters, the initial speed, 0 meters per second, the final velocity, unknown. The acceleration, that's something I do know because she's free falling. That's downward, 9.8 meters per second each second. And the time it takes to reach the water below is unknown. So those 6 kinematics variables are going to help me consider these concepts over here. So which of those 6 kinematics variables here have time but no final velocity? This one has time and final velocity, so I'm not going to choose that one. This one doesn't have any time in it at all. This one has both time and final velocity, so I'm not going to choose that one. This one has time and final velocity in it, so I'm not going to choose that one. So the one I am going to choose, of course, is the only one that's left. So I'm going to start by writing that down. Let me first get rid of those. I'm going to start by writing that down here. And then I'm going to cross out things that I know are 0, like V naught, the initial velocity is 0, so that whole term goes to 0. And Y final is 0, so that whole term goes to 0. So what I'm left with is the initial height plus the half GT squared term. And then just following the rules of algebra, subtracting Y naught from both sides and multiplying 2, dividing by G. I'm going to end up with this expression. And then a simple plug and chug is going to result in 5.05 seconds rounded to 3 significant figures. And of course, it's terribly exciting, so I'm going to put a nice big bold box around that. And then write down what it means. Time in free fall. Yay. Alright, now part B. That one's asking for the velocity of the cliff diver just before she reaches the water. So the velocity part, I know it's downward. I'll put a negative sign in front of how fast she's going. But to figure out the actual speed, I'm going to use the kinematics equation V equals V naught plus GT, because that's the one that has the final speed, the final velocity, and the time that I now know. So that's the concept. Apply that one. And it turns out to be, I guess I should have that with me. Let me clickety-clacky that one. 9.8 times 5.05, 49.5, so negative in direction, 49.5 meters per second. Of course, that's terribly exciting as well, so I'll box that one right down. Final freefall velocity. Yeah, we're almost done. So part C is asking for the average velocity, and that's pretty simple because in part C, well, anytime you're going to calculate average velocity, you're simply just looking at the midpoint between the initial and the final velocities, because all of these problems involve constant acceleration. So I can just write down V average is 1/2 of, or the average of, the beginning and ending velocities. So since the beginning velocity is 0, I can just divide that final velocity by 2, and I can get that V average is downward, that's the direction of the velocity, and the speed is 24.7 meters per second. Of course, that's a bold prediction, so I'll box that one as well and write down what it means. Average velocity. And the final part actually is kind of fun, drawing these graphs. So to draw the graphs, I'm going to make first a series of these coordinate systems. And I'm going to try to fit them all in right here. So let's see. How about, let's go the wrong way. So about, there's one. There's one. Oh, it's kind of crooked. Something like that. Like this. Crooked again. So artistic license. There we go. And then the last one. Well, watch this. I'll just shuffle those over a little bit. Donk. And then the last one is going to be about like this. Yeah, good enough. Alright, so each of these has the time axis. And then I'll make this one the position, the velocity, and the acceleration. Alright, let's go back to drawing lines here. So I've got lines like this, and I'll make them red because I can. So the acceleration is probably the simplest one to draw because it's just a horizontal line, a constant negative 9.8 meters per second each second. So I'm just going to draw that. And then the velocity is the next most complicated one, I think, because the concept is that the slope of the line on the velocity graph represents acceleration. So I'm looking for a line segment that's constantly negatively sloped, and it has to start at 0 velocity where the diver started, so something like that will do. And then the next one, I'm going to switch into this kind of a mode and think about a line or a curve that has the qualities of, I guess, 0 slope to begin with, and then ever increasing negative slopes corresponding to faster and faster and faster velocities downward. So I'm going to start up here at y naught equals like 125 meters, and then parabolic curve down to 0. And that's the solution to problem number 4.